All right, so chapter 3, section 5, we're looking at some business applications of derivatives. So I was going to look at number 2 from the homework. It says finding an average cost. So when you're doing an average cost, like this is my cost per item, but it depends on how many items I have. So I should divide by X. So whenever you're doing an average cost, or you see this C bar, it's your cost function divided by X. And so if I was looking at this one, and I wanted to find the minimum average cost, so I could put in my function. Well, this wouldn't really be my, oh, I could do it this way. And that equals 0.001 x cubed plus 5x plus 250. And honestly, unless WebAssign wants a exact value, I am fine with, once we get to word problems, just doing them with Desmos and understanding, this is average cost, I take this divided by X, and then I can find a minimum. And so if we look at this graph, we'll see, well, yes, it has a minimum. And it looks like it's right there. So my X value is 50. And that minimum cost per item will be $12.50. So that's where we get the 50 units on this one. So it's understanding what average cost means. So your cost function divided by X. Another one I want to look at is number 6. And again, it didn't give us any equation, so we're going to have to produce this equation. So they give us some information, and from there we have to do it. So when a wholesaler sold a product at $45 per unit, sales were this. So it was sold, this was the price, and my demand was this. So when the price increase was an increase of $1, so $1 more, the average number of units sold dropped to 335. Assume that the demand function is linear. What price per unit will yield a maximum total revenue? So to do that, we have to get a price equation, and we can find that here. And then to find revenue, it's price times our X value. So I would have to, let me play around with this for a second, I'll show you something. So if I put my points in of 45, 350, and then I also have the point of 46 because it's $1 more, and I went to 325. So I could actually see this. My X, which is my prices, I'm going to go from, let's say, 40 to 50. And then my demand is, oh, should I have this backwards since my price is going to be multiplied by revenue? I think I should totally do that. That's just going to help us later. So the number of units sold, oh, it affected my price. That was totally correct. Sorry. Having a senior moment. So let's get this value. So it looks like I'm going from 300 to 400, we'll say. Just so we can see those points real nice. And so here's my points. So as the price went up, my demand went down, and we can see these 2 points. If I want to find that equation that goes through them, and it's just a line, and if through any 2 points goes a line, we could use the information that we did, I think, in chapter 1, find the slope between the 2 points and then use point slope form. Or if I wanted to, I could just do a regression. So to do that, so we have these points. Sorry, I think I'm going to have to do it in a table. This may be the longer. Y'all probably already figured it out, but I'm still going to do it. So here's my 2 points. Let's get rid of these points that we made. So if I want to do a linear regression, I do the tilde, y tilde, and it's actually y1 tilde, because I want it to grab this y1 information. And then let's just do an mx1 plus b, and it'll actually give me what my slope is, negative 25, and my y-intercept. So I know that my price, oh, I did have it right before. This is my price, this is my demand. If I want to get a price equation, that needs to be my P. I should probably start over, but I think it's good for y'all to see sometimes the struggle is real and trying to figure out what you're doing with a word problem. So I still have my equation here, so my slope is negative 0.04, same thing as negative 1/25, and my B value is 59. So let me change my domain. My X values are going from, let's say, 300 to 400, and my Y's are going from, let's say, 40 to 50, because these are my prices. So I see the point, I see the line, and again, they give me my slope and my y-intercept. So I could graph that y equals, even though it's already graphed it, just so y'all believe me, since it looks like I've gone crazy. Same line, right? So here's my price equation. My price is negative 0.04 times my demand plus 59 cents, or $59. So that's how I figure out what my price will be. The more I sell, right, the lower the price gets. So now if I'm looking at a revenue equation, my revenue equation is my price, which this is my equation for price, times how many I sold, which would be X. So if I put in negative 0.04X plus 59, and then I multiply that by X, again my demand, I should get something curvy, right? So let's see if I can see that. It's orange. Oh, there it goes. It's getting up there. Maybe we could look at a good window. So if X is my price, let's say I'm going from 0 to, no, X is my quantity sold, my demand. Let's go to 0 to like 800. And then let's say my price goes from, I don't know, 30 to 60. See if I'm getting anything here. Looks like I'm missing something up here. I'm going to go higher, and that's not going to do it. Let me go lower with that price. Maybe I need to sell a whole bunch. Let's see. We see this thing taken off. It would be a quadratic, right? Because I'm multiplying. So I'm going to have to take that number up quite a bit. Let's go to... So I see that it just came down, right? So it's somewhere in between this 0 and maybe 2,000 would be a good X value. So 0 and 2,000. But now I need to go up higher, so my price might have to go up higher. Maybe 200? 2,000? Oh, jeez. Look at it go. Oh, but this isn't really my price anymore. This is my revenue. So that was my verbal mistake. So when I sell 737.5 is my items for my product, my revenue's like a bunch, right? Because I just multiplied it by X. This isn't giving me my price anymore. This was my price equation. It's giving me my revenue. And so this is the amount that I sell, and this is my revenue. So this number 737.5, that is the number of products that I've sold, right? So to figure out what is my price, well, I could just plug it in. This is my X. So negative 0.04 times where I have my maximum at. So the X value is 737.5 and then I add 59, oh no, not getting the same number. So somewhere along the way I have erred. Oh, it's 335. So that changed my equations, which means this is now changed. So my price equation is 6666. Looks to be like some version of 2/3, maybe one. I'm not even guessing. And then this is 68 1/3. So we see that I have this max at 512.5. And now I get something, oh, different equation. Here's this 34.17. So it helps if you put in the right numbers as your data points, the 335. And again, for the past like 4 minutes, y'all been saying, Boone, it's 335, not 325. Here's your equation. Here is my revenue equation. So it's my price times X is my revenue. And then once I find where this max occurs, I plug that X value into my price equation. And that'll give me the 34.17. So I will do this one algebraically. Maybe algebraically I would have done a better job. But this is nice to see how Desmos can work for you. And one more, just talking about elasticity. And so in the book, they define elasticity. So when is something elastic? So where the price changes what the demand's going to be. So if we look at something, maybe milk. Milk is something that I would consider is inelastic. We are going to buy milk regardless, right? But if something does move based off of the price, it would be more elastic. It's more movable, right? Bendable, stretchable. Where something that is inelastic, we could change prices all day and people are still going to buy it. Gas, we do reduce our travel, but people got to get to work. So the formula for that is P over X, which our P is in some form of X. So we get the price equation over X divided by the derivative of P with respect to X. So the derivative of this. So we will calculate this in a supplement. So sorry if that was painful. This is probably the longest video I've ever made for y'all, 13 minutes. But you get to see some of the struggle that can occur and put the data wrong, interpret which one's X, which one's Y. Boone is definitely fallible. So I will work on a supplement, and this is chapter 3, section 5.